Problem. Charge is distributed throughout a spherical volume of radius r with a density rho equal to alpha r squared, where alpha is a constant. Determine the electric field due to the charge at points both inside and outside the sphere. Alright, let's find the electric field inside the sphere first. Okay. So here is the sphere, and let's say we want to find, since this charge distribution is radially and spherically, it's spherically symmetric, the electric field here is all this charge doesn't produce any electric field at that. So all this charge produces a zero net electric field there. The electric field there is just due to this charge inside. Okay. So now we have to be careful setting up the integral. Okay, so let's call this distance r prime. That's the distance at which we're trying to find the electric field. Okay, so the electric field at that point is, since the charge is radially distributed, oh well, okay, we'll do it. Okay, so what I'm going to do is I'm going to draw a shell. And the electric field at this point due to the shell is as if the shell was a point charge. Okay, so now this shell, we'll call this radius r. So the charge on the shell we'll call dq. And the charge on that shell dq is the density of charge times the volume of the shell, and the volume of the shell is the surface area of the sphere, okay, which is 4 pi r squared times dr. Okay, so 4 pi r squared dr, and that is equal to alpha r squared 4 pi r squared dr. So dq is 4 pi alpha r to the power 4 dr. And dE, the electric field at this point due to the shell, is dE. And remember, as long as the point is outside the shell, this shell acts as a point charge. So dE is just k dq by r prime squared. R prime is the distance to the location at which we are finding the electric field. So dE is k 4 pi alpha r to the power 4 dr r prime squared. R prime squared, and the integral is r changes from 0 to r prime. R to the power 5 divided by 5 r to the power 5 divided by 5, 0 to r prime. Alright, let's add a page. Okay, so the electric field This is the total electric field. I should add another step. Okay, so the step is, I'll add it right here. E is dE, which is equal to that. Okay. So the electric field is K 4 pi 4 pi alpha r prime squared times r prime to the power 5 divided by 5, which is equal to 4 pi by 5 K alpha 1 over r prime squared. Okay. So there's the electric field inside the shell. And inside the shell also it falls off as 1 over r squared. Alright, now so outside the shell, now let's do the same thing for outside. So for points outside the shell, outside the sphere, we're finding the electric field at this point. And again, we'll call this distance r prime. So we'll again draw a shell. We'll call this radius r. The charge there is dq. Again, everything is the same. So dq is rho r 4 pi r squared dr. So dq is alpha r squared. So 4 pi alpha r to the power 4 dr. dE is, again, as long as you're calculating electric field on an outside point, this shell of charge acts as a point charge located there, right there. Okay, so dE is K dQ divided by r prime squared. Okay, so the total net electric field is this integral, which is equal to K dQ r prime squared. Okay. Alright, let's add a page below. So the electric field is K dQ, and by the way, so let's that radius is r. Okay. Okay, dq, what is dq? 4 pi alpha r to the power 4. Okay. Divided by r prime square. Okay. And the integration is over r, and r goes from 0 to r, capital R. So let's pull out all the constants. R prime square, 0 to r, r to the power 4 dr. So 4 pi alpha k r prime square. And this is r to the power 5, that 5. 0 to R. Now let me write it in a particular form. So E is K R prime square times 4 pi by 5 alpha R to the power 5. And this you can evaluate is going to be the total charge inside the sphere. Total charge of the sphere. And this charge is acting like a point charge as long as you're finding electric field outside. So this charge is acting like a point charge. Okay. All right, so that solves that problem.